right, good afternoon. Welcome back after lunch. I hope you had a great lunch. Maybe not too good, because I do want a bit of energy in the room, but I still see it, that's nice. But let's get the blood flowing a little bit more. Raise your hand if you're a software developer. Wow, almost all the room, this is my crowd, love it. So keep your hand raised, and keep it raised if you call yourself a software engineer. A few hands going down, but most people stay up in the air with their hands, and that's interesting, right? Software developer, software engineer, there's something in there that to some feels like, I want to be an engineer, to others it feels like, maybe there's not something right up to engineering that I live up to. So that's sort of what I want to explore in this talk, right? So the art of software development versus engineering, is there a difference? I think there is. And I'm not here to convince you that you should not call yourself a software engineer. It's all fine by me. But I do think there's also something of an art in what we do, and that's what I want to explore in this talk. That's also what I think we should embrace as software developers, because it helps us get better at our craft. So that's what I want to explore together with you. So I'm Sander, I'm from the Netherlands. I work there with a scale-up called Picnic. We do online groceries delivery in the Netherlands, France, and Germany. I'll talk a little bit more about that during the talk as it comes up. But before that, I've been involved as an IT consultant, software developer, software architect for over a decade in many other projects. So I've seen quite a few things in IT in the past 15 years. And I'm not sure if I would call all of it engineering. But you may say, hey, hold up, right? If you go back, let's say, to one of the first software conferences, it was actually called the NATO Conference on Software Engineering, 1968. Most of us were not around, at least I wasn't. So isn't this sort of a settled thing? Is software development not just engineering? And the interesting thing here is that this conference, the name of it, they actually said the phrase software engineering was deliberately chosen as being provocative. So they already knew at that point, well, maybe software development is a little bit different than other engineering disciplines, to which I think they're right. I think I agree with that. So no, this is not settled. This is really still, I think, in some sense provocative. But let's unpack that. Because what does it mean to be an engineer? Now, obviously, engineering goes back way beyond computers and software development as we do it, right? So we've had civil engineers, electrical engineers, aerospace engineers, all kinds of other engineers in all kinds of areas. And I would say, I would define engineering as applied science. There's this vast body of knowledge, for example, physics, maybe maths, other things, and as an engineer, you turn this into useful things in the real world. You build real-world objects using engineering disciplines derived from this scientific and body of knowledge. But I think another big difference in engineering versus maybe software development comes from another term, and that term is accountability. As an engineer, you're accountable, you're liable to the designs that you make. So let me ask another question. Whoever in this room has signed off on a piece of software certifying that it is bug-free? No one. And I would not sign something like that either, right? So I think in our industry, there's just much less regulation. There's no certifying bodies, etc., like you would have in other engineering disciplines. So in that sense, there's definitely a difference between what we do and what other engineers do. So I actually got triggered into this talk and thinking about this whole thing by this article that was published somewhere in Canada. And the title says, "Is software engineer an engineer?" And then a regulator in Alberta, Canada, actually says no to the companies there. You cannot call them software engineers. So you cannot have job ads for software engineers. You cannot have job roles styled that way, because it's actually really a different thing. And if you read that article, it's actually pretty interesting. It says, professional engineers are held to high professional and ethical standards and work in the public interest, it said. The public places a high degree of trust in the profession, and these layers of accountability, there's the word again, and transparency help keep Canadians safe. Wow, if you read that, you want to be an engineer, right? But it actually is something where the regulator says, well, software development is not like that. That's a bit of a pity. So what if we turn this around? What if the other engineering disciplines would be a bit more like software development? Let's say some person, business owner, comes to an engineer and says, let's build a bridge. Because let's face it, that's also sort of the level of requirements we sometimes get. And then the engineer would say, sure, I'll give you an MVP in two sprints, or maybe not even 2 sprints, it's done when it's done. That wouldn't really fly, would it? At least the bridges that come out of that, I would not cross, for sure. So then they say, okay, maybe we should do a bit more science, right? So this is translation of a body of knowledge, physics in this case, building codes, etc., into something that works and that we know that we can build, that we know that we can drive across. But luckily, in software development, we also have a science, right? Computer science. So are we then maybe more computer scientists than engineers? And I would say, obviously, I love computer science. I studied it. I think a lot of you in the room also did. But at the same time, if I look at how much I use, let's say, the actual knowledge from computer science in my day-to-day work, projects, jobs, maybe not so much, right? We do use a lot of output from computer science. We use compilers every day. We use algorithms, data structures. But how often are you, as a developer, actually doing this sort of computer science in your projects and developing these novel algorithms, data structures, etc.? Not that often, right? And don't get me wrong, I love computer science. It's very neat and precise, almost like math, right? So we have the data structures, everything in there fits perfectly. So take, for example, graphs, trees. We know trees can't have cycles, but then you have this product owner in the real world coming up to you and say, well, actually trees can have cycles, right? So this is sort of the world that we live in as software developers, on this edge between engineering, computer science, and everything else that we do. So maybe you need a different example. Maybe we need to talk about recursion. And of course, to understand recursion, you must first understand recursion. But I'm going to assume that you already have that down, because otherwise we would never finish. So yeah, of course, recursion, other super important concept from computer science. And actually very useful to understand articles like this. Hitman hires Hitman, who hires Hitman, who hires Hitman, who hires Hitman, who tells the police. It's got everything, right? It's got the suspense, it's got the drama, it has the recursion, it has a base case, where the base case is the final hitman saying, I'm not going to do a hit for this kind of money, so I'm just going to turn all of us in. So yeah, super useful, but again, this is not the be-all, end-all of software development, I would say. So of course, some of us do work in academia, and we're working on important problems like P is MP, or maybe P not as MP, I'm not sure what to root for nowadays. Yes, of course, then you're a computer scientist. But we, as developers here in the room, I think are using more of computer science outputs rather than being computer scientists. And that is fine, right? I'm not saying that there's anything wrong with that. But it just means that we're not fully software engineers. We're also maybe not fully computer scientists. So the most we use computer science is when we get a new job, I guess. At least then we whip out lead code and the data structures and algorithms. But other than that, not so much. So what are we? I think, in essence, we as a group, we as software developers, we are problem solvers for a given domain. And software development is our tool to actually solve these problems, to automate. But the domain and the problem that we're solving should be central, right? That is why we get paid, that is why we are here. And of course, then we use computer science, software engineering, everything around that to actually do this, to implement this. But I wouldn't say that this combination is actually what leads to great software. Because as we see around us, even big companies, Google, Facebook, I mean, there's outages, systems break, things go wrong. We also see projects overrunning, so we're also guilty of this ourselves. We're not fully in control. And I do think that there's also a piece of art that comes into this. And you maybe call it something different, right? And throughout the talk, we'll see that it has different facets. You could call this craft, you could call this experience. Let's explore that. But I do think that this art of software development is actually bigger than we give it credit for. All right, so congratulations. That means that you're an artist, right? Or at least in part. I hope you're happy with that. Well, some of you are, some of you maybe not. But I think it's really cool, right? What we do as software developers, as we solve these problems in these domains, we actually create something from nothing. We create solutions to problems that other people cannot solve. We automate things that could not be automated otherwise. So we're shaping the world by the software that we create. And that takes a lot of creativity. That takes a lot of artistry, I would say, to actually do what we do. And we have this infinite set of possibilities in everything that we can create and could create, that we need to select from and that we need to navigate and that we need to use to achieve the goals and solve the problems that we want to solve. So I'm actually not the only one who thinks this. There's this really nice quote from John Romero, who's one of the creators of Doom. He says, you might not think that programmers are artists, but programming is an extremely creative profession. It's logic-based creativity. And I love that quote. It brings together sort of the tension and everything what we do, right? So there's a lot of logic, math, rigidness, engineering maybe involved, but there's also so much creativity in there and so much that is not left up to, let's say, rules and regulations, and which cannot be nailed down to simple principles. So I think that is what we do, what we are, and what I want to explore. All right, some of us do practice the dark art of copy-paste-driven development, guilty as charged, not afraid to admit. But usually we're creating new stuff, right? Usually we're creating things that have not been made before and that have not been done before. So I think that's really cool to view ourselves as an artist in that way. And then some people hear this talk and come up to me and say, yeah, Sander, all well and nice, but are you now calling me an amateur because I'm an artist? To which I say, really? Do you think artists are amateurs? I fully disagree with that, right? These are people, these are masters in their art. They dedicate to their craft, they get better at it. All the works of art we see in museums, actually most of them have been commissioned. People get paid for this, which is sort of the definition of being a professional. So I would say being an artist is definitely not saying that you're an amateur. Obviously, there's sometimes a little bit of mixing between art and amateurs. You remember this one? I'm not talking about that, right? So I'm talking about real artists, real masters who craft their works and who actually change the world by the art that they make, like hopefully we also do as software developers. So if I were to summarize software development in a single word that is also relevant to this art of software development, then I would say what we do is abstraction. Now what do we mean by that? Well, we take real-world problems, real-world issues, and we look at them, we take the essence out of this, and create software, create abstractions to actually solve these problems. So like I mentioned, I work with Picnic. We're an online groceries scale-up in the Netherlands. And so what we do is we offer an app to people, they can order their groceries, and then they get them delivered at the doorstep next day. Sounds super simple, but if you look at the whole chain here, there's so much software and so much problems to be solved that are involved here. So we need to have vehicles driving around, need to be routed, we need to have planning for the fulfillment of orders, we need to have an app up and running all the time, we need to have a purchase order management for our own groceries buying, etc. So there's a ton of issues that we need to abstract here, and we cannot just say we're going to do it all with software, right? We need to look at this. And I view our developers, our development team, as in this sense also being artists and looking at the real world and then creating a picture that is actually pleasing, relevant, and abstracts away irrelevant details and leaves us with a system that supports the goals that we want to achieve as a company. So in a sense, then the IDE is your canvas and the code is your paint that you are using to actually create this work of art, supporting the business processes, supporting the business goals that you have together in the company. Now, of course, this is not just about code, right? So if you look at the whole cycle, we have development coding, we have testing, we maybe have some design, there's some process around this. And I think for each of these steps, we can try to identify, okay, where's sort of the artistry in there, and what can we learn from that? So I want to take these in turn and then talk about these now. So let's get started with code. I think all of our favorites, right? Because in the end, code is the truth, I would say. You can have the best process, you can have the best design, you can have the best testers, but if your code doesn't work, if your code doesn't work right, then you have nothing, right? You have nothing to ship, you have nothing to show for. So what makes good code? Let's think a little bit about that. So what we see here is, of course, the Mona Lisa, widely regarded as one of the most beautiful paintings in the world. And you can ask the same question, what makes this a good painting? Right? Is it the haunting eyes? Is it the use of color? Is it, I don't know? Or is there also a principle behind this? Is there something more that we can learn from the art that we see here than just the picture? Who knows this? Anyone? Yeah, it's the golden ratio, right? So, yes, there's something more going on if you look a little bit deeper. And that doesn't mean that every piece of art has to use or is using the golden ratio. It's just that if we look at a lot of pleasing pictures and paintings, etc., we can recognize this as a principle of something that is applied when you create a good piece of art, a good painting, a good picture. So what then could be a good principle of good code? Is it something like this? I'm not completely sure. So there's something very aesthetically pleasing about this Street Fighter sort of indenting this code like this. But that's not exactly what I'm going for. So I'm not really talking about what the code looks like visually, although some people do. So there's this very nice submission to the International Obfuscated C contest. Very creative, but that is not what I'm talking about when I talk about the art of software development and then when I talk about good code. So formatting is not it. And in fact, I would say there's actually beauty in uniformity there. So what I would highly recommend everyone to do is to actually sort of automate this discussion around formatting, etc., away. So at Picnic, we write a lot of Java code, so we use Google Java formats as something that, by default, just formats the code in a way that we decided up front. If you're doing Go, it's not an issue anyway. You have Go FMT and everything built in there. So this is not really what we're talking about when we're talking about art and good code, in my opinion. So back to the painting again. What are we talking about then? Anyone knows why this painting was made? I guess not. I'll tell you now. So there was this guy in Italy called Francesco del Giocondo. And remember, this was before Instagram. So he wanted the painting of his wife, just a pretty painting, right? And as you do in these times, then you go to a painter and you say, hey, I want a pretty picture of my wife. Can you make this happen? I'm going to pay you for it. And that is sort of the reason why Leonardo da Vinci actually made this painting, right? It was commissioned. There was a reason for it to be there. And it wasn't there because he wanted to practice his golden ratio or try to practice his new brush, etc. It's really about something he did for a given purpose. Now, little aside, the painting was actually not sold to Francesco because Leonardo showed it to a French king who had much more money and sort of outbid him. So in the end, the painting did not end up where it was supposed to end up. I'm not saying this as advice for your code to sell it to the highest bidder, but anyway, what I'm getting at is that good code always has a reason to exist. And this sounds very logical and obvious. I would phrase it as good code is useful code, so it solves an actual problem and it solves it well. But I can guarantee you, if you actually approach your pull request reviews in a way where you, for each line or for each section of code, you ask the question is, how is it solving my problem? Why is it solving my problem? And is it doing it in a way that it really effectively solves my problem? You will approach it in quite a different way, and you will see kind of different discussions on pull requests than you might normally see. Now, of course, the purpose and the use of code is very context and domain dependent, but there's also a more, let's say, cross-cutting concern that we want to take into account when we talk about good code and the art of writing good code, and that's quality, right? We all love writing code, but we also know that code is read much more often than it's written. So it's up to us as developers, as craftsmen, to make sure that the code that we write is actually good, high-quality code that can be maintained for a long time, that's readable for others, and that is as to the point as possible. And we'll talk a bit more about what it means as well. And then lastly, I would say that the context of the code, so everything that surrounds it, is also super important in writing good code, right? So we all know these people who join a new team and then start frantically creating huge pull requests, doing everything else in a different way, bringing change, etc. That is something that I think is not the right way to do this. So good code actually fits into the context that is already there. And of course, this context might be quite different in different domains, right? If you are doing game development, creating a game engine, then what is good code in this context is quite different than when you're doing, I don't know, enterprise microservices development, or when you are doing maybe factory automation, PLC code, etc. So there's really a lot of factors that go into actually writing good code and assessing whether code is good. So the first and the last, they're pretty context dependent, so I won't dive too much into that, but we can talk a bit more about quality. Because a lot has been written about quality of code in our industry, right? Almost sounds like it's engineering and it's all a solved problem because we have these books, we have these principles. Probably clean code is the most well-known one, but the other ones are also pretty nice. But to me, it only shows at least one thing, that we're really good at creating acronyms as software developers, right? As you can see here, there's quite a few there. You probably know most of them. And I think the risk here is that we read these books, we think, hey, that sounds pretty nice, let's apply it. Let's apply it everywhere. And that's where we go wrong. That's not how it works. These are not engineering books of follow this rule and it will magically work. Because there's also a bit of tension between quite a few of these principles. If you think about it, you have KISS, keep it simple. Usually, if you want to do that, it's sometimes a trade-off whether you maybe copy and modify a little bit of code or apply, don't repeat yourself. and sort of try to find an abstraction. But if you do it too early, then you might also end up in a bind. So there's a tension between these principles, and you cannot just blindly apply them just everywhere at every turn that you see. So that's also something of an art to recognize how this works in your context, what this means for the quality of the code in your teams, in your company, and how you want to involve this in your software development process. So what I want to encourage you to do here is to actually find your style. And by that, I don't mean your personal style, but as a team, as a company, decide on what it is that you feel, that you think is good code, and then try to engineer as much of it as possible away. So what do we mean by that? Well, sometimes you look at pull requests and you see things like this. First one that says, okay, can we add a space after if? And the second one says, well, maybe how about using optional.isEmpty instead of not optional.isPresent? And the last one is about, well, you should use the overload of this method, which takes a time zone explicitly, because otherwise it will mess up. All somewhat valid points. And it's okay maybe to discuss this once or twice, but if this keeps coming up, this is really not the discussion you want to have in code review, right? You really want to talk about the first thing I mentioned. Is this actually a useful way of solving our problem? Do we solve the problem the right way? Do we have the right abstractions? And this is all noise and distraction, even though it's important. So what you can do here, there's actually a whole host of tools that you can use to automate a lot of these decisions away. So there's in the Java space, there's Spotbugs and ArchUnit. More generally, you have SonarQube to do this in a lot of languages. And there's even a class of tools like ErrorProne and OpenRewrite that take it a step further and don't just point out issues in code, but they can also automatically fix it for you. So that is something that you can do after you have this discussion once or twice, maybe in your team, to actually encode this into these tools and make sure that you don't have to bother with this anymore. And just to give a quick example, at Picnic, we're pretty heavy users of ErrorProne, which is a Java-based tool, where you can really easily automate these things and actually have this rewritten for you. And it looks a little bit like this. It's super easy. You can create a before template where you say, okay, match this kind of code, where it says not optional is empty, and then rewrite it to something where you have optional is present. Super simple, but we don't have to discuss this anymore in any pull request at all. It will be automatically applied, and there's no discussion anymore. And you can focus on things that really matter. So if you want to know more about that, at DevOps 22, I had a really in-depth talk about this tooling. If you're also a Java developer, I highly recommend to do that. But to me, it's more about the principle, right? So if you have this sort of style, these agreements, all the way from formatting to API users to all kinds of other technical concerns, automate this away as much as possible using the tools that are appropriate for your tech stack. Now, the risk here is thinking that it's all about the tools, that the tools are the point. No, that's really not the case. That's not what I want to say here. The tools are a means for you to automate some of the things that you feel as a software developer, as an artist in your field, are important, and that you, together with your team, decide upon that makes good code, that makes good software. Because imagine if a painter would obsess about sort of the tools that they use, like the brushes, etc. It would be really counterproductive, right? So, you know, Vincent van Gogh actually lived around this time frame, 1885. And it's a rarely known fact that Reddit was also around at the time, one of the oldest social media. And there's this painting subreddit where then Van Gogh is known to be posting. And he says, it's Van Gogh, the one-ear man, by the way. Hey guys, I need some advice on which brush to use for my next masterpiece. Any recommendations? And then Monet comes by. Van Gogh, seriously, your paintings look like a mess. Use fine brushes to provide the finesse and control needed for true artistry. And then Van Gogh responds, and notice how he doesn't understand threading, but I mean, it's 1885, he's forgiven. I find fine brushes so boring. I like to use a fan brush to create interesting textures. And then Renard comes along and says, fan brushes are overrated. Van Gogh, filbert brushes, where's that for blending colors, etc. This is bike shedding, right? This is really Vim versus Emacs, tabs versus spaces. This is super counterproductive. In the end, it doesn't matter. Even if you have great technique, great tools, if you don't create works that actually impact the world around you, that actually change, transform, inspire others, as an artist, as a painter, but also as a software developer, then it doesn't really matter. These are just tools. So a good craftsman never blames tools, but also doesn't obsess about the tools that they use. So I would say, if you're interested in this line of thinking, there's this really cool site called boringtechnology.club, which sounds very boring, but it's actually quite interesting if you look at this site and sort of the ideas behind this around using proven technology and then using innovation tokens for things to explore and to extend your knowledge and tool sets, etc. So if you're a little bit prone to resume-driven development and picking up things from conferences like these and then trying them out, maybe it's a good one to check out and see how this applies to you. All right. All to say, good code is obviously important, but in the end, it doesn't really matter to your users. They will never see your code. They will only care about the value that you deliver. But of course, then it's up to us as software developers, as craftsmen, as software artists, to actually take care of the quality of the code. Because we also know that if we don't do that, then we will not be able to keep on delivering this value, right? So there's this fine balance and tension between value delivered and the quality of the things that we do that we need to pay attention to and that we need to take care of. And tools can help, but they're certainly not the be-all, end-all of this question. All right, so we talked about coding. There's also this thing called testing, of course. So first of all, people think testing is meant to prove that a system works. Well, it can't, of course, but we can try to find flaws. Let's say, try to break shit as a tester, right? So in that sense, it's a little bit like creative destruction. And I think it's a really interesting field. I'm not a tester myself, but a lot of testers do exploratory testing and just mess around a little bit in the system and try to find bugs and problems. And then you see this huge smile on their face if they actually manage to break your system and then file a bug report and you have to fix it. They take a screenshot and share it with you. But that is not what I'm going to talk about, because we're all developers here. So I really want to talk about unit testing. So what makes good tests? I think similar to the question, what makes good code, we can also ask that question. Now, I hope we can all agree that there's sort of a principle behind tests that you want to follow, where you have this sort of arrange, act, assert kind of structure in there, where you try to make sure that the context is right, that you actually invoke the right action, and then also assert something around what you just tried to do and want to test. So yes, tests should assert an outcome, because otherwise it's useless. But then there's a lot of questions that come up here, right? So, for example, should this be one assertion in a test? Or can this also be multiple? Or what is it that we want to do there as a developer group? What kind of libraries do we want to use? In the Java space, do you use JUnit assertions or AssertJ or another library? I would say these are all interesting questions, but they're more on the engineering side, right? And also here, if you discuss this and you make a choice, use your tooling to actually enforce this and to not ever have this discussion again. So that's fairly straightforward, I would say, but as we progress up the stack of this test, it becomes more interesting and it becomes also more like the art that we talked about. So if we look at the middle part of a test, I think this is where the magic happens, or where it can happen at least, because a test in the end is not just there to prevent regressions, but if you write it during your implementation, maybe even before if you're in the TDD camp, it should also drive the design of your code. It should drive the design of whatever you're trying to do, your APIs and everything behind that. And then it becomes more interesting, right? Then you ask questions like, is this test that I'm currently writing maybe even over-constraining the implementation that I'm creating on the other side of the test? And does this test actually cover enough? And I'm not talking really about code coverage, because we all know code coverage doesn't tell too much either. But it's really about the art of having small enough tests that are independently useful, but at the same time also don't over-constrain your implementation. And there's not a lot of tools that can help you there. And there's also not a lot of courses in university that teach you this, right? So there's a lot of experience, artistry, and things going on there that are not captured. And as you go up, then of course questions like, how do we keep these tests maintainable, understandable? How can we ensure that they maybe even act as documentation, which would be great. Then you have questions like, are we using marking or not? Are we going to share data between tests? And there's pros and cons of doing that. So all these kind of more design-oriented questions around tests are really, I would say, in the realm of the art of software development, and not so much on this engineering side where you can just encode a few rules, make sure things are in place as you would want them as at the bottom that we saw before. And this all points a little bit to the fact that code is not just code, but code usually also has a design. So I want to talk a little bit about design as well. And I'm not talking about UX design and sort of pretty pictures, but I'm really talking about architecture and sort of design, high-level design of code. Also known as, do we even need this stuff? We're agile now, right? Do we have to do design? And I can sort of see where this is coming from. As I said, I've been around for a while, more than 15 years. So I've also been subjected to this software architecture art that some people create. I show you the early 21st century, late 20th century recognizable box and arrow style of software architecture. This is not what I'm really talking about when I talk about design of code, right? Of course, it's nice to have pretty pictures, but we may have been a bit too heavy on the big upfront design thing in the early stages of software development. But then again, people have declared design and architecture dead at the same point as XP and Scrum and iterative development became into fashion because, well, why would we need to do any design if we are just going to try things and iterate and incrementally deliver anyway, right? And Martin Fowler actually published this article way back when, in 2004, and asked the question, is design dead? Well, spoiler alert, in this article he argues, no, it's not dead, because we still need to invest a little bit upfront to actually understand whether we are building the right thing, making trade-offs and making them explicit, and making these choices upfront to prevent later changes that might be even more costly, uncovering risks and assumptions by doing software design, and maybe even more importantly, also having a bit of documentation. And this maybe sounds like a shock to some people who are doing Agile and say, okay, we don't write documentation, the code is the documentation. Well, good luck telling that to your teammate who onboards into your team, hundreds of pages of lines of code. That is not going to fly. So you want a bit of having rationale and description and maybe visualization of your system as well. And doing software design and software architecture helps with that. Now, of course, I'm not arguing for going back to the whole big design upfront thing again, but there's certainly a middle ground here that we can attend to. Because I can tell you, weeks of coding can save you hours of designing. It's up to you. So, if you want to know more about that, there's a great talk by Salman Brown, The Lost Art of Software Design. You can see how I would like this title. He's actually also at this conference and has a talk and a slot after this, so I highly recommend going there. It's a different talk, but related. But I think it hits on a nerve in our industry which really needs to be hit, because I think the pendulum needs to swing a bit more into the design direction. And why is this maybe not so easy to achieve? Well, I think a lot of developers actually see this as a very creative but also really daunting part of software development, right? Why? Well, unlike when writing code, there's no compiler to actually yell at you if you make a mistake in software design or in a software architecture, right? The feedback loops are quite different, from minutes to maybe weeks or even months to see the results of the choices that you make in the resilience of your system and all kinds of other qualities that don't easily express into single pull requests and lines of code. And in software design and software architecture, there's rarely ever a best solution. It's trade-offs all the way down. And that is something that we need to get used to and also get familiarized with, because it's all about exploring these trade-offs, maybe documenting them, making them explicit, but there's no perfect solution here. It also requires you to really understand your domain and the problem that you're trying to solve before you even start writing a single line of code, which is not an easy task, but it is worth it if you are actually using this knowledge to inform your design and create a good architecture. And lastly, design is not just the act of designing, but it's also very much communication of this design to others, maybe to managers, leadership, the team around you, people who need to know about what you intend with your design. And this is interacting with people, and that's actually quite hard, as we know, right? So all in all, this discipline of software design is certainly not trivial. So other than any sort of guiding principles like we had with good code and good tests, well, I want to point out at least one, which is simplification. We probably all know this quote from Pascal, where he said, if I had more time, I would have written a shorter letter, right? So if we translate this a little bit to the software design and software architecture context, we might say that if only I had more time, I would have created a simpler architecture. Said no developer ever. Right? So somehow we're drawn to complexity, to actually bringing in more technologies, expanding the scope of things, adding more edge cases, making things more complex. And you start to wonder, why is that? And I actually didn't really have an answer until I actually ran across this very interesting article in Nature magazine, which is really not software development oriented, but it's a general problem-solving kind of analysis. And they actually found out that in general, people like to solve problems by adding stuff rather than taking stuff away. So here they had a test with some Lego blocks, and they said, okay, your goal is to make this a stable structure. And then people started adding 3 of these support blocks to make a stable structure. But of course, if you would just take 1 block away, you would also have a stable structure, right? But almost no one does that. And why is that? That's an interesting question. I think the same is happening also in software design and software architecture. It's very easy to bolt on some new ideas, to actually add more complexity, to add more things. But if we start thinking about our software architectures as something that need to fulfill constraints that we have to understand, that live in a certain context that we also are to understand, then we can also think about what is already there. How can I shape that? Maybe take a little bit away here, add a little bit there, rather than setting up something completely new, something completely different to solve the problem. So then we're actually looking at this more as a sculptor, right? Where you take parts away until you have something that actually is pleasing, that is solving your problem, that is actually what you want. And there's this another quote that perfectly aligns with this, which says, perfection is achieved when there's nothing left to take away. So if you would approach software design and software architecture more with this mindset, then I think we can be more successful there as well. All right, then I also mentioned that it's really also about communication, right? It's not just holding up in your attic and coming up with the best software design or architecture ever. We also need to bring this to others and communicate this. And there we can also learn from the art of storytelling, because storytelling is really about taking a certain situation and describing it in a way where you capture the creativity, but also bring structure into your communication, where you communicate complex ideas in a simple manner, maybe even use visualization in there. And there's lots of cool and interesting insights from the storytelling side that help there. But when you see this, when I see this, I actually think of a lot of design documentation and things that we do in our companies, right? Writing a design documents, RFCs, or architectural decision records, whatever it is that you use. These are all conveying complex information, hopefully in a simplified way, using visualizations, etc. So if we see ourselves as people who want to get better at this, then I think looking at the art of storytelling can also really help us here. Even though it's completely unrelated to software development, I think mastering this will help us also communicate our ideas better in terms of software design and architecture. Of course, that still requires a design to be there, to communicate. And for that, there's the tried and true approaches, like, for example, domain-driven design, event storming. Won't go into that too deeply here, but there's all kinds of supporting processes and things that can help you here. But how do you actually get better at this? Because usually when you need to design a new feature, a new big thing, there's a lot at stake, right? You're not going to give this to someone who has never done this before and say, okay, good luck, we'll see what happens. Usually it's more the experienced people who do this, but how do you gain this experience? And that's actually pretty hard. So you might shadow someone, might look along, that helps. But what we actually did in Picnic is also just try to introduce some deliberate practice with this. So we have a workshop internally where we ask developers to create a design for a fictional new feature, for an actual system that exists. So we provide a little bit of context, a little bit of the ideas about the new feature, and then we ask them in pairs to come up with an RFC, because RFCs are the way we structure our new design efforts, software design efforts, and we ask them to come up with an RFC for that. And it's actually super interesting if we do this in like 4 or 5 groups to come together and see, okay, but how did you design this, and how did you come to this trade-off, and why? And these conversations are really insightful and really help people to understand what the driving forces are in software design and software architecture. So I highly recommend doing that if you don't do something like that already in your company. All right, so we talked about codes, testing, design, and architecture. There's also this thing called process, right? Also known as, is it done yet? So what about process? Well, some people think this is a solved problem. There's many standards. There's even this ISO standards around software development lifecycle and all these kind of things around the process, which of course we all don't know it doesn't work, right? These big frameworks, these big overarching approaches to software development, it's all some kind of illusion of control. You actually have to pay for this standard. I would not recommend. If you read the introduction, it's already bad enough, so I shudder at the thought of reading the whole document. But I think we all know that Agile is nature's way of telling us that software development isn't really this strict engineering discipline as the document before would have you believe. But it still means that there's a wide and vast array of doing Agile within our industry, right? All the way from the very loosey-goosey spec by Slack. So your PO sends you a Slack message, you say, oh, sounds good, I'll implement it. All the way to this thing called Scrum Fall, where people pretend to do Scrum, but still have big yearly plannings and release trains and things like that. So there's a wide range here. And although we all feel that Agile and being flexible helps us, you're probably now waiting for me to give you some kind of insights from the art of software development into process and say, okay, guys, it's all going to be fine. Well, I'm sorry, there's no silver bullet here. I don't have the magical insight in terms of software development process to help you. But maybe we should turn the question a little bit around and talk about maybe we should be focusing on processes, but more on the teams. Because a process might be something that your company sort of rolls out, decides, hard to influence. But a team, the way you interact, the way you are a team together, that's something that you can influence, that you can change tomorrow if you want to. So there's a few things there. I think it really helps to be very explicit in expectations towards each other, towards yourself, also towards the outside environment. It's too often that we are very vague in our commitments, that we are very vague in what we do. So try to be more explicit, but do this with empathy, right? So it's very easy to make big demands, but it also works the other way around, right? What commitments do you make to yourself, and how would you expect others to act in there? Because in the end, a lot of people profess they want to have a lot of autonomy, that they want to have autonomous teams, which I fully agree with, but it requires a level of trust that you need to gain by actually having commitments that you meet and having other people's trust to have this autonomy. Also means that you need to give this trust to others, right? So it works both ways. So in this sense, if you can also already work towards that as a team, it doesn't really matter what process you have. If you adhere to these principles, I think you will be in for a much better team experience, and especially if you couple this with a continuous learning and growth mindset, where you make space for people to fail, to actually stumble and learn from that, but also make space to actively learn new things together. Then I think you're in a team and in a place that is very healthy, even though the bigger context may not be that healthy. So if there's one book you want to read about process, don't read a book about process, read a book about people. This one, Peopleware, it's a classic, it's an older one, but I really highly recommend it. So if you focus on a team, if you have a good team, you can evolve a good process. You can even survive a bad process. But the other way around, if you have a team that doesn't function in this way, even the best process won't save you. So again, read Peopleware and focus on how you apply this in your day-to-day with people very closely around you. So you might have the question, that all sounds very good, but apparently there's a lot of things in here that are not easily maybe transmissible in book learning, etc. So how do we learn this stuff? Is this just experience? Do we just need more years of experience? Well, yeah, maybe a little bit. Some people actually turn this into the question, how do I get the right knowledge? So who has these books, by the way, from Don Knuth? That's for you. Did you read it? No, me either. But even if you were to read this cover to cover, it would not make you a great software developer. You would be very smart, you would know a lot about data structures, algorithms, etc. But as we saw, there's much more to software development than that. So maybe the question isn't even right. So we shouldn't be asking how do we get the right knowledge. Maybe we should talk about how do we get the right skills. And as I said, I'm from the Netherlands, I'm Dutch. So I ride a bike, which is an acquired skill, I would say. But there's actually books about this. I was surprised. There's this Bicycle Riding 101, and this is actually on Amazon. I'm not sure what's in there. Maybe it just says, get on, pedal, try not to fall. I don't know. It would be a very short book. But we all know this is not going to work, right? And then some pedantic people might say, yeah, I mean, this is a for dummies book. You need something more rigorous. To which I give you this amazing article by Bartosz Cichanowski, 15K words on how a bicycle works, all the physics that are implied, everything that's happening there. It has amazing animations, great explanation. But even if you read this all the way through, you will not become a cyclist. For that, you need to get up, You need to fall, you need to experience some pain, you need to try again, and then you will at some point be able to ride a bike. So I think the term that we're looking for is maybe somewhere among what we saw already. And there's this term, metis, which I think really nicely captures this. And it translates into something like wisdom, skill, or craft. And this is actually something I counted in a book called Seeing Like a State, which is totally not software development related, but still a great book. It says, metis, it resists simplification into deductive principles which can successfully be transmitted through book learning, because the environments in which it is exercised are so complex and non-repeatable that formal procedures are impossible to apply. And I think this is exactly what is happening in software development. We are not in a very rigid, well-defined landscape where we have a vast body of scientific knowledge that we can easily translate into rules and regulations and engineering discipline. No, we're much more in this space of applying some of the principles, but also having this wisdom, skill, and craft available to us. So I think in our education and in bringing people here, we should go back maybe a bit more to people and not turn to books. So what I really like is sort of the approach of taking more the guild-like approach, which the original masters of art also did, right? They had guilds, they were masters, they had apprentices. And this is actually a movement that you see also a little bit in education coming back, where this Wall Street Journal article also notes that more students are turning away from college and towards apprenticeships. Germany has a big culture on this as well. So I think there's a lot of value there also for what we do as software developers. So within Picnic, we also are experimenting with this a little bit. We call this our Tech Academy, which is a program where we offer people right out of university a job, but they won't get into a team and then have to just sink or swim. But we actually give them 50% of the time to grow and to learn. But crucially, we also couple a mentor to them for at least half a year that will really walk them through this metis, all this wisdom and craft, help them apply and translate what they learned in university to actual software development in the real world. And of course, we also offer some material, some access to courses, etc. But that's not really the point. I think the most important part here is this master-apprenticeship kind of relation where people grow very fast. And that is how you learn the art of software development. So what can you do in that sense? It depends a little bit on where you are in your journey. If you are early in your career, I think it really is helpful to find this mentor to help you discover this art of software development. If you're a bit further along, then you can be this mentor to someone else. So I think that's a very valuable way of going about that. And it doesn't have to be inside of your company, can be, but it can also be as part of a community. Look around you. I mean, there's many people here who can benefit from your experience or vice versa. Can also be in user groups and in other places. So don't think too small in that sense. Now, as we wrap up, if we maybe are artists in some way, maybe in a small way, then we should also leave a legacy, like real artists also do, right? So I want to ask you, are you working on what matters? And sometimes you just need a little bit of a wake-up call, right? So if you have this capability, if you are this software developer, this software developer artist, are you actually changing the world in a way that is meaningful to you? And if not, well, there's places where you can do that, right? So think about that. That's our purpose. That's why we are here. And then this craftsmanship, we can shape it with the tools, but again, the tools are really not the point. They are just there to support you in engineering your style and making sure that everything that you do fits into the bigger picture of creating useful solutions in the domain that you're working in. And finally, like I said, become a mentor or find a mentor. And there's also this mythical discussion usually of the 10x developer, so someone who's 10 times more productive, which I think is a bit toxic. But I think you can be a 10x developer in a different way. If throughout your whole career you help 10 people get 10% further by mentoring them, by helping them grow, then to me you are a 10x developer in a much more useful way than this sort of 10 times productive being a developer yourself. And of course, I really hope that you get a bit of recognition before you die, unlike some of the big masters in the art of painting, etc. But I hope that will be fine. All right. So if you want to read more about how at Picnic we apply the art of software development, I highly recommend you checking out our engineering blog, as pointed out there, or come work with us, also fine. But for now, I want to leave you with the words, go forth and write some beautiful code. Thank you.